Sounds good. Thanks, Jesse, and thanks everyone for joining. So it's been an exciting month, actually. Sometimes things get quiet during the summer, but in the case of KitOps, it did not. In fact, what we've seen that's so kind of exciting for us and empowering is a big shift in how KitOps is being used and who's downloading KitOps. So in the early days, what we saw was a lot of kind of individual developers, maybe, kind of hobbyist students, people just trying to experiment with it. And that was, of course, awesome. That's great. We love that. But what's shifted in the last month or two is we've seen a real rise in the number of downloads that have all the hallmarks of coming from a CI/CD system. That's a big deal because KitOps's goal, of course, is to package everything in your AI/ML project and make it stored in the enterprise registry so that all the tools you already have, like your CI/CD pipelines, can easily grab it and use it with something like Kubeflow or KServe, Knative Kubernetes, but also non-Kubernetes platforms, anything that needs a container. And so seeing that usage increase for CI/CD type polls really shows that this is no longer just individuals. Now this is teams, this is whole enterprises. And just to kind of add to that, we had a reach out from the head of AI engineering at DSV. Now, for those in Europe, you might know DSV, especially if you're in Scandinavia. But outside of Europe, you may not be as familiar. So DSV is actually one of the world's largest logistics providers. They're, I think last year, I might get this wrong, I apologize, but I think it was $24 billion in revenue globally. They recently acquired DB Schechter in Germany this year. So huge, huge logistics company, 160,000 people worldwide. They have completely standardized on KitOps. And the way they're using it, I just wanted to share this because I think it was really, really smart. And I think it's something that a lot of enterprises can benefit from. As you can imagine, they have a lot of different divisions, a lot of different teams doing a lot of different kinds of AI, some predictive, some Gen AI, maybe it's LLM stuff and computer vision. And so they knew that they weren't going to be able to get kind of a one size fits all a set of tooling for all these different use cases and all these different teams. But they did need some predictability, some consistency, some kind of reliability in what lands in production. They knew they needed to be able to operate that from around the world, follow the sun from different teams. And so you can't have 20 different technologies and tools being used across your org if you need to try to support things in production that way. So what they said, and I thought this was quite clever, is every project will start with a KitOps model pack. So they have a set of kind of approved models. That's a mix of models from like Hugging Face, but it's also models that they've built internally or have tuned internally for their specific use cases. So those appear in kind of a catalog. They're all model kits. Every team is told you can start any project you want. You just got to start from one of these. If you don't find something you need, they have a whole mechanism for kind of nominating things into that catalog. So now a team grabs a model kit and they've got kind of a base model that they can work with. Then DSV said, for the development part, use whatever tools make sense to you. And I think that's the smart part because different models need different tools, different use cases need different tools. And so it gives those teams a freedom to self-determine this is the right tool for me, that's the right tool for me, this is the right tool for the project. And so that's what we're going to use to develop this model further for my specific use case in my specific division or team. Then, once the model's all ready, then it comes back to KitOps again. And they say nothing goes to production until it's a KitOps model kit and it's been gone through their security tests. They have a bunch of other tests they need to do. But critically for this community and ecosystem, I think it's really exciting that they've kind of standardized on saying it's a KitOps model kit. And that way it can go to Kubernetes, it can go to other container platforms. They use Azure, they use Google, and they use AWS, as well as some on-prem and edge deployments. So they kind of have the whole gamut. And the nice thing is that, of course, model kits work perfectly with all those different serving inference endpoints. So I wanted to share that partly because it's just exciting to have yet another giant organization standardizing on KitOps. You may have heard in the past that Pacific Northwest National Lab, which is one of the largest national laboratories in the United States, and they have over $1.6 billion that is deployed to helping research projects. They've also standardized on KitOps in much the same way, kind of as that parentheses, if you will, around what the teams are doing. Start with KitOps, end with KitOps. Stuff you do in the middle is your business. And so I thought that the pattern of usage there is also really valuable. And it doesn't need to be an organization of 160,000. I think the same thing works for an organization of 50 people or 100 people or 1,000 people. So that's awesome. In addition, so that's KitOps. And oh, by the way, I think Jesse can confirm the exact number, but I think we're getting close to, or maybe crested yet another download milestone, which is awesome. Now let's talk about the model pack side. So model pack may be new for some of you. So just bear with me for a second and I'll give you a little bit of a rundown of what model pack is. So KitOps has been around since February of 2024. Yeah, so a little over a year and a half, I guess. And when we built KitOps right from the beginning, we said two things. We said, one, we're building this because we want there to be a standard, a vendor neutral, interoperable standard, so that if you need to change tools the way DSV does for different projects, you're not actually going and having to redo all your pipelines and redo all your data and redo everything else. So that's what KitOps does, and it does an awesome job of it, of course. But we also knew that people would want a kind of higher level, more abstracted specification that would allow them kind of a guide to build their own tools, because they may not want something exactly like KitOps. Maybe they want something a little more tied to their particular serving platform or their particular development platform. And so we began work on the specification, which is called Model Pack. That is also a CNCF project like KitOps. And Model Pack has gotten to the point now where it has been published. It is an official CNCF project and specification, and the kind of CLI for it is just starting to be built out. The great thing about that is that we've got support for Model Pack from huge organizations that have kind of joined on: Red Hat, PayPal, Ant Group, ByteDance, and even Docker has said that they are likely to adopt the Model Pack specification for their tools. So it's really already starting to get that industry tailwind, if you will. Super exciting. And again, if you're using KitOps, you're effectively using model packs. Angel's going to talk about this a little more here in a second as we talk about the upcoming releases. But the model pack specification is kind of 90 to 95% identical to KitOps. So obviously, as you can imagine, we built both of them. So that's kind of understandable. All right. So that's kind of, I guess, the big news. Jesse, did I miss anything?
No, I think that's it. And also, I'll apologize. I think I didn't unmute myself for the whole intro. So if you just saw me talking and no sound coming out, my apologies. Again, welcome to the call. We have Angel who's joining us now to talk about uh, the KitOps release that's coming. I also messed up Angel's calendar, which is why he was late. So now he's here. We're good to go. Angel, take it away.
All right, yeah, got the late invite, came in here. Yeah, I have a small slide deck here I can share. Um, so yeah, this is my usual HackMD slide deck for the KitOps updates. Um, this stuff is not currently released, but some of it will be coming out in a release that I will probably be doing later today. And so you can try anything you see here, you can try out in a few hours. I love the cold launch. No, no announcement of what's to come. Here it is. It's available immediately. So yeah, the first thing that we're adding here is thanks to actually a community contributor, the new KitOps releases are going to include SBOMs generated by Sift. So one of the things we talk a lot about is security and immutability and details on model kits. And community member noticed that we weren't actually doing that for our binary releases for the CLI. So those will now be available. They'll be bundled alongside the release artifacts on GitHub, so you can check those or import those as you need to. And that should just be part of the next release. We haven't tested it yet because this will be the first release where we try to do it, but fingers crossed there will be no issues and we'll be able to just get this out the door. Additionally, Gorkum, who couldn't join us today, added model kit reference support for the dev command. So now you can do kit dev start and specify a model reference rather than a local directory. If it's something that you've pulled locally, Kit will unpack it and run dev mode on it. And if it's something that you don't have locally, Kit will download it from the internet, unpack it locally, and let you start it up. So this is a quick way to like just run a quick dev server. You get a nice browser-based interface for interacting with your LLM. Currently only supports GGUF LLMs, but if there's a lot of interest, we can always look into adding support for different formats. And yeah, this is a very useful one because previously you used to have to, unpack the model, which meant you have to store it somewhere, you have to find a directory to put it in, all of this stuff. Now it's all automatic. It all gets put into a cache directory that gets automatically cleaned, and you can kind of start and stop these things at will, play around with different LLMs, see how strange the suggestions are from the really tiny ones. They don't really have the size to support fully natural conversation, so it looks like you're talking to a child. It's great. Give it a shot, or try it with a bigger one, and it can actually be quite useful. Um, the last thing I want to talk about today is we're finally adding shell completions to KitOps. So previously, you used to be able to get shell completions in Kit by it was always built in, right? You could auto complete the different commands we have, the different flags, but we didn't have auto completion for the actual model kit references, and those can get quite tedious to type out depending on your registry or organization, or the way that model repositories are often structured with 7b dash instruct. They're long references. They're kind of tedious to type. So now instead of doing that, you can just, if you have a model kit locally, you can just hit tab and it will autocomplete the rest of the text. It'll autocomplete tags for you. It'll autocomplete digests for you. And so you could just type a few characters, press tab, and save yourself a lot of typing. This is one that I've personally wanted for months, and I finally found time to add it to Kit. So next release, we'll have this included. And yeah, as Brad was mentioning, the sort of last thing, the next thing we're working on in the coming weeks is going to be model pack support in KitOps. That spec is reaching a level of maturity where it's relatively stable and not as much of a moving target anymore. And also, as Brad mentioned, I assume before I joined, we've been contributing to the model pack spec. We've been participating in those discussions. There's a community call every other Thursday if anyone else is interested in joining. You can find it on the CNCF Slack. There's a model pack or a model spec channel. I can't remember. Um, but yeah, we want to actually add support as a first level support for model pack in Kit. So it is similar to the model kit specification. We kind of started the model kit stuff before model pack got off the ground, so they are a little different. And we'll probably still continue to do model pack or model kit support as the sort of primary in Kit, since we control it fully. But we will there's a lot of compatibility between the two, and so we will add support for model pack and KitOps. That'll let you, push, pull, pack, unpack, do most of the usual stuff, except with model packs. So if you are using another tool that works on model packs, Kit will work with it too, as will any CI systems or automation that you write using Kit. Cool. That's all I have for today. I'll pass it back to you, Jesse.
Yeah, thanks so
Just
much.
quickly, sorry, before we go to Jesse, just to clarify, on Gal, since you were asking, the CNCF Slack channel is hashtag model pack. So if you're in the CNCF Slack and you just look for model pack, you'll find it there, and you can chat with all the contributors and maintainers there. Thanks.
Thanks, Brad.
Perfect. Well, thank you, Angel. That was awesome. I'm very excited for the SBOM support. I know it's something that has been talked about quite a bit. And with that, I will hand it over to Shivai, who is going to be talking about KitOps, and KServe. So Shiva, are you still with us?
Yes, yes. Give me just 1 minute.
All right.
Just share my screen. Just one second. All right, just 1 second. All right, I hope you're able to see me. Let me quickly go ahead and share my screen. And the entire screen. Okay. So I just wanted to quickly give a bit of context into. By the way, please let me know, Jesse, if you're able to see my screen.
Yeah, we can see your screen.
All right, perfect. Yeah. So before we jump into the main talking points for the integration, first I just want to kind of talk first about what exactly is KServe, right? So if you talk about an entire end-to-end machine learning cycle deployment, it starts with the training of your model, and then you have to package your model, and that's where KitOps and model kit are a great way to be able to take your model and treat it as a first class OCI artifact, and you can deploy it with all of the additional metadata like your documents, all of your code files, and maybe like metadata related to hyperparameter tuning, and you can of course serve that. Now that's just one part of the story, but the other part of it is to also then have a really robust inference pipeline, which means that once you have trained the model and you want to deploy it into production so that you can do inference with it, you need to have a really good, solid open source project that can allow you to do that. And KServe is actually one of those. So KServe is an open source tool that is primarily for serving machine learning models. Like let's say once you have built or trained a model, KServe will basically help you to deploy it into production so that it can respond to your prediction requests. So that's for your inference, right? And KServe architecturally is primarily built on Kubernetes, and so that's why if you look at an end-to-end life cycle of taking a machine learning model where you're training it and now you want to do the inference in production, this combination of KitOps or model kits with KServe allow you to get that entire end-to-end machine learning life cycle. So right from packaging your models with model kit and then finally going ahead and integrating KServe that will allow you to get the actual inference, right? So the idea even for this entire end-to-end lifecycle is that you want to have reliability, versioning, and have the supply chain security. So this is what you get from KitOps, and at the same time you need to have some scalable inferencing capabilities. So that's what you'll get from KServe, where you get auto scaling or like let's say exposure via API. So the entire idea here is that we'll kind of give you a quick overview of the entire end-to-end step-by-step workflow of how that all of this kind of comes into picture, right from creation of a model kit. So you've probably already seen, if you have been regularly attending our meetups, you have probably already seen that how it's really easy to create a model kit. So you just have your application code or your machine learning code, you use a git pack command, you do git push, and depending on whatever OCI registry that you have created, you have basically initialized with your git login command, you can go ahead and publish your model kit over there. Now, that's the first part, which is you package your model into the model kit, and this includes your model weights, metadata, versions, or any other dependencies that you need. Now, the next step is that you need to have a Kubernetes cluster, and that cluster needs to have KServe installed. So in this case, for example, you can see that if I go ahead and just one second. So if I run a quick command for KServe, and for documentation, you can just quickly, go to the KServe documentation site, and that will give you, oh, I think I'm also out of the actual, okay, let me go into an SSH into my, okay, 1 second. Yeah, 1 second. So let me go into my account. So what I'm just doing is that just to kind of give you an idea that I'm running a remote cluster where I have deployed this into a VM. So my entire infrastructure is running on a remote VM. So I'll just quickly go ahead and also log in into my cluster here, and then I can quickly show you the installation process for KServe and how that works. And then we'll talk about the end-to-end step-by-step guide. So I just want to ensure that, yeah, perfect. So I should be able to log in. Let me just add the password again. Okay, just 1 second. I might not have Okay, let's see. All right, so it's just starting the shell, perfect. And then I can go and show you. So if I just run this command, you can see that right now I have KServe. So as I mentioned that KServe is a platform built on top of Kubernetes. Now, the great thing about KServe is that you can also run this with Kubeflow. So Kubeflow is in fact like an end-to-end machine learning platform for right from, taking, like, let's say talking about being able to store your model artifacts into like a Kubeflow registry, to having Kubeflow notebooks, Kubeflow pipelines that allow you to define your entire machine learning cycle. And then when it comes to the inference, so KServe also has an integration with Kubeflow. But if you're not using Kubeflow, you can also just use KServe standalone. And we'll talk through the entire step-by-step process of what it takes to do the inference, and especially if you are trying to deploy a machine learning model that has been packaged as a model kit, how you can do that. So the first thing is just to install KServe, and the documentation for that, you can just go to the KServe documentation on getting started. So I'll just quickly walk you through what all things you need. So you need to first like just create and I'll just go to quick start guide. So you need kubectl. You need to have at least one, a Kubernetes instance. So in this case, I'm using a kind cluster, and then you just have to install it via this command. You need to have Helm as well. And once you have verified that yes, your KServe is working, you'll see that these are the two different or the pods that you're running. So in this case, if you look at the namespace, that's what I just ran. So these are the two pods that show that yes, KServe is running. So this the controller manager and your local model manager. So this are the two main priorities. So this is what is the next step. So first is that you have already created your model kit. The next step is to ensure that you have KServe setting up. And then the third one is that basically, if you also go through a documentation, there is this one particular important point, which is build KitOps KServe image. So this is hosted on the GitHub registry. So basically, the idea is that this is going to be a container image that knows how to unpack your model kits, which is being able to fetch it from the GitOps storage and open them up so that KServe can use the model inside. So that's one of the more important prerequisites. And then in order for us to basically use this, you'll see that what we do is that we are installing a cluster storage container. So the idea here is that you configure your KServe with what's called as a cluster storage container. In this case, we can call it KitOps. You can see that we have an example of this over here. And so the idea is that this cluster storage container, the main idea here is that whenever a model's storage URI, so in this case, whenever it starts with kit, then use this container image to fetch and unpack your model kit. So that's what we are trying to basically say. So that's the prefix. So the idea is that, as the documentation also says, that after applying this manifest, because when you're using KServe, you have to create an inference service, and that's the service like similar to how you create your deployments and services inside of Kubernetes. You have to create an inference service that tells that okay, this is the model that KServe will be used for inferencing, right? So what we're basically saying is that we configure our KServe instance with this cluster storage container, which says that whenever a model storage URI begins with kit, it should use the container image to fetch and unpack the model kit. Because in this case, what we're trying to do is that we are trying to pair up a safe way of being able to secure your machine learning models with KitOps with a model kit. So it needs to be unpacked by the KServe, and then whatever model that we are using inside the model kit, it should be used. So similarly, I have also done that. If you look here, I have created for myself. If you look at the list of all of these, I can quickly show you, what my KitOps cluster storage container looks like. So it's very similar to what you see directly, in our documentation. And now you just have to apply it. And if you want to just quickly check like what that looks like, so I'll just quickly run that particular command as well. So in this case, you can run a kubectl get cluster container KitOps. So that just shows you that yes, now this particular this cluster object cluster storage container is active. So that tells us that yes, now we have to go ahead and fetch and unpack the model kit. So that's the next step. Now, the next step after this is that you have to basically go ahead and create inference service. So that's our KServe's inference service that refers to your model, where over here you can share that your storage URI. So this would be where your actual model kit is being stored, right? So this will be used for your model kit reference. So for example, if you're storing your model kit on Zozo Hub, then it would be KitOps zozo.ml slash or forward slash your name of the user. So that would be like Shivai Lamba, and then the name of the not the registry, but like let's say the repository and the tag that you're using with that. So you basically write a YAML spec for your KServe inference service that refers to your model, and you specify the storage URI, and then you can also basically share the model format, because depending on what the model format might be, it might be like let's say a TensorFlow model or a sklearn model or a GGov model. So because there are so many different types of machine learning model providers, you might choose one, and depending on so in this case, this example is a fairly straightforward iris model. But if you already know, then with KitOps or at least with Zozo Hub, there are a bunch of different types of model providers that you can use. So if when you're deploying it on, let's say, Kubernetes, you can deploy it with VLLM or with GGov based models. So here you just define the model format, and so the idea is that you can also configure this a bit further. So once you have gone ahead and defined the actual inference option, you also get some configuration options that you can add. So these are like some extra knobs that you can tweak. So for example, this unpack flag command is used to pass extra options when you're unpacking your model kit, or it could also be used to handle credentials, especially if your model kits are being stored in some registry which is private. So maybe you might want to add that username and password, or for example, if you want some specific cloud provider settings, for example, if you want to add like let's say an AWS ECR permissions via IRSA. So if you're adding some IAM based permissions, so that's like the entire idea, that you can configure those. And so the next use case here is that, and that's something that I was not able to get running. This some slight error, but your next step is pretty much that you will be defining your YAML file for the actual inference, and then you go ahead and serve that. So the next step is you create that inference file, you apply it, and then when you now run KServe, you can use port forwarding. So in fact, like we have a guide for Kubernetes. It kind of will work in a similar way. So if you look at the Kubernetes deployment for KitOps, there are some dedicated guides on, for example, like how you can deploy a model kit with Kubernetes. There's a dedicated guide on that, where you create an init container, and then you basically expose the pods, your pod on like let's port 8080, and then you make a curl request to that pod, and then you're able to get a result. So it will be very similar use case, that once you have created your cluster storage container, you create your YAML where you define where exactly is your model kit, and add some extra params for like let's say if your model kit is being stored in a more secure registry, then you might have to give your username and password, and then you just use the KServe. So for example, here you can see that this is how you make your first ever GenAI inference service. So you create the inference service. In this case, the storage URI instead of Hugging Face would be with KitOps. So that's where your Zozo Hub image would be there, and we'll have a prefix of Kit starting over here, and then you can get to know the inference status. And if you want to, of course, add like let's say an ingress IP, or if you the simplest example, if you're running this locally, would be you just use port forwarding, and then you go ahead and perform your inference. So it's very similar to how you do it with Kubernetes, but with KServe you get built-in inference capabilities that it's deployable, and you can very easily pair this up with an entire end-to-end workflow with Kubeflow. So that's like the high-level overview, right, of all of these things. Now, some of the most important things to keep in mind is as we kind of as I can kind of conclude what we have already covered is, so I just want to cover a few things. So the first one, as I mentioned, is the storage URI, because this is where we signal to KServe to use the GitOps storage container to fetch that model, right? So normally KServe would use something like Hugging Face or S3, but of course when you're using KitOps as your storage for the model, it's far more secure as compared to an S3 or a GCS location or a local path, because, or even Hugging Face, because you get the capability of being able to audit the model. You have built-in capabilities to secure, like scan the model as well with model scan, or even verify the model by using Sigstore, right, or cosine. So it's a lot better. And then, as we mentioned that early, like the last thing is this credentials. So if your model kit is, like as I mentioned, stored in a registry that requires you to have a login, then KitOps inside the container needs those credentials. So this could be supplied either with the help of, like, let's say, Kubernetes secrets, or if you have an environment variable, so you can also use those. So those is like the high level overview of what is possible today with KServe. And the reason why you might want to invest in KServe is that, whether we talk about, so if you talk about the entire landscape of LLM inference with Kubernetes, that's the hot topic today, right? Just with 1.3, with Kubernetes 1.34 release, I think now we have what we call as dynamic resource allocation. And this entire idea is that with dynamic resource allocation, it's now a feature that is in beta for a while, and now, yes, it is in stable release. So what it does is that you can dynamically allocate how, probably, like, let's say you have pods that have GPUs running, so you can proactively do things like GPU sharding, or maybe, and all of this is required because as companies are, not just working with, not the smaller models, but they are now running multiple agents. So you might need a entire orchestration of multiple LLMs that you're running at the same time. And as LLMs overall context windows also increase, so that means that you need to have more firepower when it comes to, like, leveraging multiple GPUs at the same time. So projects like VLLM or LLMD, like, for example, even vCluster, they are all being designed to be able to, like, run inferencing more effectively, or even for training. But at the fulcrum of all of this lies being able to, like, securely access these models, or having a place where you can securely store these models after the training, or maybe like after the fine tuning process. So that is why the combination of something like Model Kit, which provides you that ability to save your models in a really safe manner, and then serving them with the help of KServe, on built on top of that entire Kubernetes infrastructure, that provides you an end-to-end lifecycle of a production-ready machine learning workflow. So, of course, I didn't show you the entire thing because I got stuck into an issue, and maybe, like, we'll also publish a blog post around a more in-depth case of, like, whatever things we covered today. And we'll be showing that. But yes, if you are already using Model Kit with Kubernetes, it's very similar with KServe. It just provides you an abstraction layer on top where you don't have to, like, write everything from scratch, like having to create a YAML for the deployment and then having to work with, like, let's say, VLLM on Kubernetes. Like, all of that abstraction is taken away from you with the help of KServe. So the combination of Kubeflow, KServe, and KitOps, or KitOps and KServe is a great way to build an entire end-to-end machine learning pipeline. So yeah, I think that's it from my side. Jesse, if there are any questions, would love to gather those. Otherwise, I hope everyone at least understood this end-to-end workflow.
Yeah, awesome. Thank you for that, Shivai. We do have about a 30-second buffering delay, so we'll watch the chat and see if anything rolls in. While we do that, Shivai, you're actually speaking at a KServe event tomorrow, correct?
Yeah. So exactly, you can find that in the CNCF Slack. So it's called as a crash backoff loop. The entire idea is that you, as a developer, you are an enthusiast for the CNCF projects, and you don't know anything about that CNCF project, and you go and you basically see yourself that how would you try to understand conceptually. So you're just randomly trying out the commands. Now, of course, this is probably an exception for me because I've worked a bit with KServe, but the entire idea is that you essentially learn from someone who is trying out these projects for the first time, right? So imagine that someone comes to GitOps documentation for the first time, and they do not know anything about GitOps, they don't know anything about machine learning. So when you are, like, literally reading the getting started page, or even the product page for the first time, what are the thoughts, and how do you make inference about okay, like what this project is all about, how to get started with it. So it's a very very unique way because a lot of times what people get scared is that even with GitOps, they might get scared that oh, this is a machine learning project or it's related to infra and machine learning. I don't know anything about that. But if you give it a read, if you use like let's say ChatGPT a bit to understand the docs, you can now understand conceptually a lot of these things. And especially, I think it also relates back to people who are trying to make open source contributions to GitOps that you can use today ChatGPT. In fact, like there's this tool called DeepWiki. It essentially takes your entire GitHub repository and gives you a really well structured documentation on each and every function and how the different parts of the project are related to each other. So this is a great way for you to get upskilled and you don't have to now rely or wait for a maintainer to get back to you. You can do this on self-serve capability. So even with like this crash backup loop, initiative, it's just like, okay, how can you be a self-starter and learn about concepts that you might not be aware of? So I think that also applies to people who are looking to contribute to GitOps or trying to build projects with GitOps. You just have to go ahead and build, and of course, the Discord community is really great because Brad, Jesse, Angel, and then Gorkum from the core Zozo team and the core maintainers, and then all of the plethora of the contributors that are there. They are active on Slack, on Discord, and they'll be more than happy to answer your questions.
Yeah, absolutely. Actually, if anyone in the chat is looking at Discord, if there are any questions over there, feel free to paste them in. My computer does not like when I open up YouTube and Discord at the same time.
I don't see anything right now, Jesse. I did want to do a quick shout out. If anyone on the line is in Toronto, October 9th at 5:30, I'll be speaking at the Toronto Enterprise DevOps User Group. You can find that on Meetup. We'll paste a link into the chat as well. But I'll be speaking about KitOps and about just generally how you can use your enterprise registry as your model registry, save yourself some money, make things a little bit simpler, avoid mismatched auth-Z type issues that you can get when you have multiple registries and multiple sources of truth. So love to see you there.
All right. Awesome. Well, I don't see any questions. Shivai, thank you for joining us. Angel, thank you for joining us. And Brad, thank you for joining us. Let's see. It looks like that link to Brad's talk came in. I'll drop it into YouTube here. And there you go. So everyone should have access to it.
Thanks, Jesse.
Yep, of course. All right. Thanks, everyone. Have a great rest of your day, and we'll look forward to seeing everyone at the next community call.
Thanks all. Thanks for being part of the community.
Thanks, everyone.
See y'all.